Welcome. Welcome to ME364, heat transfer, elementary heat transfer, I guess. It doesn't mean it's easy, it just means it's sort of your introduction to it. I'm Mike, Professor Mike Wagner. You can call me Mike if you like, that's fine. I'm a faculty in mechanical engineering. I can tell you a little bit about myself. First, I'm in the engineering research building, so if you want to stop by my office, the tall building, right, go up to the top floor. I'm right out the elevators, which happen to not be working today, so that's fun. And then my email is right there. There's several other Mike Wagners on campus, including journalism and medical faculty, so make sure you get the right Mike Wagner for emailing me. So you're free to contact me, stop by, whatever makes sense. So I'm glad to see you all here. It's a full class. Should be a lot of fun this semester. What I want to do today is kind of go through my expectations first for the class. I think it's fair to give you guys a bit of background information, just kind of what you need to know to be successful, what the expectations are. And then we'll get into the actual first bit of material right away. So any questions or anything before I get started? Nobody's brave enough to ask the first question of the semester? Okay. All right. So a little bit about the course. I guess read the syllabus. This is all there. But I'll give you the highlights. So there's 3 TAs for the class. Justin, Viraj, and Pele. You probably should have knowledge of who your TA is. But if you don't know your section or figure out your section, you can just look up who your TA is. That's their email address. I guess probably the first thing you want to do is talk to the TA while you're in class physically. If something comes up, there's some conflict or something, you can always email them. Like you can email me as well. The class, if you don't know, is set up where you got traditional lectures Monday, Wednesday, and then Tuesday, Thursday, we have these discussion sections. So rather than have like 3 lectures and a lab, we have 2 lectures, and then a lot of time we actually spend solving problems, right? The point of the discussion section is to go sit down with a specific problem, walk through it with your class, with the TA, figure out how to solve heat transfer problems, right? So a lot of like the lecture, we'll go through some examples, but the real like substantial examples are saved for discussion. You do have to, discussion is mandatory. I guess we'll get to that stuff later. There's a weekly homework assignment. Again, I'll talk more about that. For this class, there's 2 midterms. In terms of the scheduling, we'll do a midterm. The first 2 will be in class, so I'll try to have you arrive like 5 minutes earlier than scheduled, and then stay 5 minutes late, so you have a full hour. But they should be finishable in that amount of time. And then there's the final exam. I think we'll just stick with the scheduled final time, which is on your Canvas page. There's a textbook for the class. It's called Intro to Engineering Heat Transfer. I've got the colors reversed. Let me just, so you can see what it, so the actual book is that. So it's black, orange cover. There's a blue book by the same authors, Nellis and Klein. If you happen to get the blue book, it's fine. It just goes into a lot more depth than this one. So if you intend on, say, going to grad school and taking a heat transfer class in grad school, you might want to get the blue one. A lot of the content is the same, but this is more tailored to this specific class. Okay. In terms of whether the book is required, I guess I won't go as far as saying it's required, like I'm not assigning stuff out of the book. I'm not asking that you bring it to exams or anything, but it's probably a useful reference for you, and it's probably good to have. So I would say it's strongly recommended. Okay. Okay, so let's just talk through what my expectations are for the different segments of the class. Again, if any questions come up, feel free to stop and ask. That's totally fine. So what I'll do is, for lectures, I'm going to provide you with like skeleton notes or kind of blank notes. I think I emailed you. Should have gotten that. If you, by the way, didn't get the email that was to the whole class, let me know afterwards, and I'll make sure you're on the list. So I'll provide you these notes. You can use them or not. They're useful so you don't have to like copy down drawings and stuff. And they help kind of structure as we go through the lectures. I will record the lectures, hopefully. I intend to be recording this lecture right now. We'll see if it works. I will post the lecture recordings when I get a chance. So that's usually like within about a day. What that means is you'll have them available for you for like future reference if you want to go back and look at notes. It means also that they probably won't be available before the discussion. So I can't guarantee that I'll have them posted like the same night. So that means you probably do want to attend lecture even though the recording is available because you'll be doing a problem on the lecture material the following day, okay? All right, lecture attendance policy. I don't take attendance. I care that you're here, but I don't care enough to take attendance. I want you to be here, I expect you to be here, but you're adults, you can deal with that. So if you are here, don't just be here to be physically present. Actually pay attention, please, and don't distract others by playing games on your phone or something. Please ask questions. I know in this setting it's hard to have the courage to ask questions, but if you're thinking it, others are probably too, or maybe I didn't explain something well, or very, very rarely there's a typo or a mistake, not that rarely. So you can call me out on that and ask questions about it, okay? Okay, so discussions, what we expect there. Like I said, you're solving actual problems in discussion. So there's, like, weekly you get these homework assignments. We'll talk about those. They're a little harder than the discussion problems. The discussion is supposed to be like, not easy, but straightforward. Like there's relatively well laid out steps that you follow. You go through it with your TA, with your classmates. You should be able to complete the assignment before you leave. You're graded based on completion and a good effort at being right. If there's significant issues or significant errors, you might get points taken off. But you're expected to do that, and attendance is required for those. I guess I didn't put it up here. If you have to miss discussion, I'm allowing up to 2 free drops. So your 2 lowest scores will be dropped. I guess there's 2 discussions a week, so roughly 30 or so. Well, it's probably less than that. Was that probably 20, maybe 20, 25 discussions? So you get to drop the 2 lowest scores, right? Even if you attend and you happen to get a 9 or something out of 10, you can drop those. If you're in a situation where you're going to have to miss discussion, it's probably a good time to use your drop, right? You don't necessarily want to have to make that up. So kind of save them for when you need them. Don't just skip because you feel like it. So the problems and other stuff in this class, we use ease a lot. How many of you have used ease before? I should ask, how many haven't used ease before? Okay, a couple. So if it's been a while or you haven't used ease before, learn how to use it. We'll be using it enough, and there's enough kind of nuance with the software that it's good to spend some time. I have resources. I think I posted like a video playlist that you can look at. There's ways to just kind of become familiar with it a little bit, and then as you go through the class, you'll be more familiar. If it has been a while, it's a good idea to just do it. Like just go through some stuff just to refresh yourself, right? Because you'll run into ease debugging at some point in the semester, and you want to kind of know what you're doing. How you use ease is you go to the XenApp thing, this remote.engr.with.edu. You can run it remotely or like load it onto your machine and then run it that way. There's also this option to install, so you can go to the CAE website and install it. I think the XenApp is probably easier, and you're going to have less problems doing that. Okay, questions so far? Okay. All right. Homework. So homework is weekly, roughly. I mean, I think there's like 11 that I've got planned. So roughly weekly, and then not the weeks of exams. They'll be due, I think, I'm not 100% on this, but I think I'm thinking towards 11:59 p.m. I don't really care. But I'll give you guys, say, the full day to have it turned in. The due date is usually Friday for the first 8, and then after Thanksgiving break, I think it switches to Wednesday. But so plan on Friday by Friday evening you submitted the homework. It's typically 1, maybe 2 problems, multiple parts, What the intent is for you to have these actual problems that are kind of challenging. I mean, it's not supposed to be like frustrating or impossible, but they're challenging, right? You're going to spend time on the homework. I think the place where you're going to learn the most in this class is on the homework. So yeah, there's multiple steps you'll walk through. You'll solve actual problems. Like these are taken from problems that I face in the research that I do, that other faculty deal with, that other students or grad students are facing. They're simplified in some ways, but they're real problems. And so coming out of this class, if nothing else, I want you all to be able to know how to solve practical problems in heat transfer and really other in energy systems using a software tool, right? We happen to use ease. In your job, it might be Excel, fine. It might be Python or MATLAB, whatever your employer has, totally fine. But once you learn it in one platform, it's translatable, right? So that's really the objective that I want from this class. They're 20 points. You'll probably, the minimum that you get off is like 1 point if you make a mistake. So they're graded for both correctness and completeness, so show your work. Yeah, question?
When we're showing your work in ease, do you just want us to use comments?
Yeah, so for ease code, this is a great question. So the question was, if you're doing showing work in ease, do you want us to use comments or want you to use comments? Yes. So your ease code should have abundant comments so that the person grading it can figure out what you did, right? So you need comments. You should be printing out the equations window, the solution window, and any plots, right? There's some specific guidance in the syllabus that you can look at, but what you provide for your ease code should be enough that the grader can look at it and see, you got the right answer, here's how you did it, all the information that you need to go with it. If you happen to be printing out or doing a parametric table, don't print the whole thing out because that's really a waste of paper or waste of people's time. So yeah, okay, graded for correctness and show your work. So in past semesters, by the way, this is like maybe a minor thing. In past semesters, we've made people do this cover sheet on every assignment. I don't think I'm going to do that. I heard a lot of grumbling about it prior semesters. So rather than have you do basically an executive summary, I'm not going to have you do that. What I will want you to do, though, is make sure when you're noting your final answers, you're very clear, right? So if it becomes a problem for the graders or the TAs who are grading, that if they can't tell what your answer is, then we'll go to cover sheet. So save yourself the hassle, and let's do it the right way to begin with. Just make sure you're very clear about what your answer is, okay? All right, so exams, 2 in-class exams, final exam. Closed book, so again, you don't need to buy the book to have it here. What I like to do is give you 2 pages, so that's like 2 pieces of paper, right? Front and back, so 4 sides per exam, right? So if you take the first exam, that's 2. The second exam is 4. The final, it's 6, okay? 6 front and back. So as you're going through the semester, as you're taking notes and you maybe note something important, just keep a running note sheet or use it as like a review tool before the exam. So I've found that to be pretty helpful, and then it kind of puts everybody on a level playing field in terms of you got the book or you don't, and it doesn't really matter. There will be both conceptual questions and worked problems on the exam, so you got to be familiar with the overall concepts, being able to sketch plots if you're asked to do that, and work problems. You probably need a calculator. If I am good enough at writing exams, you don't, but that's not usually the case. So, okay, questions on that? Okay. Not too many more of these boring slides, and we'll get through to the good stuff. Okay, how to get help. So I'll just give you my expectations of what this is going to look like. Sorry, this is wrong. Office hours would be not this window. So I think it's 12 to 1, and then 1 to 2. So how you get help. So first, office hours. Ask questions in class, of course. Office hours are a really good way to get help. If you don't wait until you are struggling. If you are struggling, it's fine. Don't wait till you're struggling to come to office hours or feel like it's a failure on your part if you have to come to office hours. I really enjoy like talking with you all during office hours, learning about what you're doing and what your interests are, and trying to help if I can. So if I just sit there by myself in office hours, it's really depressing. So come even if you just want to, learn a little bit more about something else. So Wednesday office hours, I'm still looking for a room. I might do it in my office. It gets a little crowded. Maybe I'll find a room. I'll let you know. Thursday office hours, I'll probably do by Zoom. So if you're more comfortable joining in office hours on Zoom, we'll do it that way. So first priority would be you need help, office hours. Second would be post a piazza. I mean, honestly, it's like equal 1, 2. So we'll have a piazza discussion board set up. It's organized by like homework number or exam or whatever it is. So maybe post to the right place. So that's options 1 and 2. Option 3 would be like emailing me for help. That's like low down on the list. I get a lot of emails, so it's hard for me to respond sometimes. If I don't respond within 24 hours, it's okay to bug me about it. It just means I saw it and was doing something else and couldn't respond. But kind of give me a little bit of space there to have time to respond. Stop by my office, totally fine. I may or may not be there, just depending on the busyness of my schedule, but I'd like that if you want to do that. And then if you have requests like, can I turn in homework a week late or whatever, you can ask, but just keep in mind what's fair for everybody. So that's kind of my guiding principle. All right, so let's see. Last thing, my recommendations on how to do well. You can take this or completely ignore it, but this is sort of what I've noticed. No single thing dominates the grading. So if you decide I'm going to do really well in homework and completely blow off discussion, you're probably not going to get better than a C, right? It's mathematically, it's hard. So you want to kind of split your time equally, make sure you get into a routine. So go to lecture, you follow along, go to discussion, do the problem that goes with the lecture, and then do the homework, and that you'll kind of be fine. Office hours are useful even if you're not struggling. Use ease early and often. Refresh yourself on solutions to differential equations. So this class is a math class disguised as an engineering class, right? There's a lot of math. So refresh yourself on how you solve differential equations, right? The goal of a differential equation is to express something in terms of a rate and then relate it to some property. So like think of temperature. So we're going to be deriving rates in terms of temperature and trying to solve for that expression of temperature. It's good to remember how to do that particular thing. Develop intuition, so predict behavior before you solve the problem, and it'll really help you think through it. Okay? Okay. That's all the upfront stuff I have. Any questions before we get started? Okay, yeah.
Are you going to be specifically stating when we should or shouldn't use these for a problem, or is it just going to be like any problem can really be used for these?
So the question was, am I going to tell you when to use ease or not for a given problem? I think it'll be relatively clear from the problem statement, like if there's numbers given and a system of equations that you probably want to use ease. If you decide that, or if you could do it analytically by hand, or in some way without using ease, that's fine. But I think a lot of times it'll be pretty clear. So if I ask for like plot this thing or run a sensitivity on this aspect, it's an ease problem. If you're not sure, you can ask, and I'll tell you. It's usually fine to do that. Okay, anything else? Yep.
For homework, do you want handwritten solutions as well as ease code, or just ease code?
Good question. So for the homework, I would like anything that you do, like hand derivation, which is not everything's going to end up in your ease code, or you'll end up with the final solution. You put that in ease. Anything that leads you up to that point of the equations that's written by hand, you'll have to scan into a PDF, upload it all together. So for homework, what I want you to do is upload a single PDF that's everything, so hand derivation plus ease code onto Canvas for every assignment. So that's how we'll be turning things in. I don't want paper submissions for homework, okay? So learn how to do the single PDF. You guys all know how to do that, but yeah, good question. Anything else? Okay. All right. So let's actually talk about heat transfer.